All right, we're doing good. We're rolling. We entered our data, we averaged it, we got the range, standard deviations. Also, we can see that some things off. Like when we're predicting, our prediction at 180 degrees has a range of 10 and a standard deviation of 5. So there's some things going on there. And then we created a plot. We got our trend line data, right? We want to copy that out of here and place it in this next section, in section 3, so we can have the equation for our actual distance, right? What does this mean though? What this means is, I'll just place or distance is equal to, I can type 0.417 times the angle, that pull angle, plus what? 19.8. That's what that means. And that our R squared value we received was about 0.989, okay? So good. So type those in. And then let's say a guess. Let's say we wanted a catapult guess at 60, right? How, like what distance would we predict? Like okay, our catapult distance is 60. What angle would give us a 60 centimeters? What angle would that be? All right. So we just need to solve for this, right? Okay. So this would be, let me just place it off to the side right here. It would be we want to take the distance, right? This distance here. We would want to subtract the 19.8, and then we would divide by the 0.417. Okay, so how does that look in our equation? You see what we did? This is just like y equals mx plus b. This is just like the linear equation of a slope, right? So what we're doing, now we're going to place in an equal sign. We're going to say, what is that distance? Is 60. So let's just point to that one, minus the 19.8, and we're going to divide it by 0.417. So what this is saying essentially, and let's get rid of some of those significant digits, what it's saying, and we can move this over here, is that 96.4, that is the angle that it's predicting, right? So here we got 96.4. Is that right? So at an angle of 96.4, will we get about 60? Yeah, you can kind of see that. If the angle is a little larger, let's say about 100, it should be somewhere between 52 and 77. Let's look at that somewhere else again. So if the angle is about 100, right, we should get a distance of about, hey, that says about 60-ish, right? But we want to improve this to make it very predictable, okay? So this is what I want you to do. I want you to run it at 60 degrees 3 more times, okay? So your prediction every time should be 60, right? So that's this, equals 60, okay? Equals 60. All those are 60 because that's my prediction, right? I want you to compare that after you run it, um, at this angle of 96.4. Maybe you're going to average that out to 95. Crank it to 95, and this should be an angle equal to whatever you had above. This one is whatever you had above. And then compare it. So let's say that the actual distance you got is 50, and then you got a 45, and then you got a 65, right? And this is our range. This value minus this value, okay? So here you go. Let's just copy that on down. I'm showing you some more skills here. All right. So you can see, man, this range is high. The difference between my prediction, my actual is high. And I kind of got an indication about that from the data. I need to feed more data into this system. I could see, at these higher angles, the 135 and 180. Look at that. My range and my standard deviation were getting higher and higher, right? So what do I need to do? Well, look at the design. Let's look at the design. Is it something in the base? Maybe the base isn't stable. Take a look at it when you're actually performing this test. Is there something in this cup that's not stable, right? Is this thing, kind of wobbling about the fulcrum? It's a lot of different things you can take a look at. So change something in the design and start the process all over, on another sheet. All right. That's how you make a better prediction.